Alright guys. Hi guys. Hoping more of you guys would actually show. Did go send a message on Google Classroom. Have you guys show. I mean, this is for anybody. Anybody who's a regular subscriber to my channel, or anybody who's actually in the classes that I do teach. Alright. We're looking at E instruction. Again, I'll try to link this in the live streams afterwards. We're looking at E instruction. In this case, it's not the introduction to probability. This is the worksheet that's on independent events, Common Core Algebra 2. So let me just start off by reading it, right? It says, in the previous lesson, homework, we saw how the occurrences of one event could change the probability of another. When this happens, we say the two events are not independent of one another. When the occurrence of one event has no effect on the probability of another event happening, we say the events are independent. Now, exercise 1 says, classify each of the following scenarios as having events that are dependent or events that are independent, right? So we're looking at example 1. It says a person pulls a red marble out of a bag that has 5 blue and 7 red marbles and does not replace it, right? Then a person pulls another red marbles. Is the probability of pulling the second red marble out dependent on pulling the first red marble out? That's obviously, it's darn dependent, because it says that he does not replace it. So you reduce the probability. So you reduce the probability of getting another red. Right? 2 says a person flips a coin and notes that it comes up heads. Then the person rolls a standard 6-sided die and notes that it comes up as a number less than 3. Is the probability that the number came up less than 3 dependent upon getting heads when flipping a coin? Explain. No, absolutely not, because one is a die, the other is a coin. They aren't even connected to each other. So that's totally out of it. Now it says the idea of independence is one that comes fairly naturally, but it is important in order to see if there are associations among two events. Let's develop a tool to develop dependence. The spinner below is spun once, and its outcome is noted. Let E be the event of getting an even. Let P be the event of getting a prime. And let L be the event of getting a number less than 5. Find the following probabilities. The probability of getting an even is going to be what? Well, from 1 to 8, how many evens do we have? We have 1, 2, 3, 4. 4 over 8. So it's about half. 50% chance. The probability of getting an even given the outcome was a prime number. So initially the number was a prime number. So there's only one prime even number out there, which is 2. So would be what? Given it, so the probability of it happening would be what? 1 over 8, right? Because it's 2. Just the number 2. That's only prime. That's also even. C says the probability of getting an even given that the outcome was a number less than 5. So we want, remember, there's plenty of restrictions on the overall results. Less than 5, there's 4 numbers. Even, so it's 2. So it's going to be 2 over 8. Sorry, actually it says given that the outcome was a number less than, so you had an outcome that the total outcome that you had was less than 5. Now the probability of an event over that, so that's going to be 2 over 4, which is going to be 1/2. If you understand what I'm saying. Which event does E depend on? P or L? How can you tell? What is a reasonable test? So we're talking about event E. So E is the even number, right? Chance of getting an even number. Which event? So does it depend on the probability of getting the outcome of a prime number, or I would say it's more dependent upon L, mainly because that restricts your pool, your overall pool. Of answers. That's an answer. Let's look at. Did I get the back side of this? I believe I did. I get the back side of this too. Alright, so let me take a snippet of that. I know I've seen a lot of these questions on the Regents exam. All right, so let's look at it. There's 2 events, A and B, are defined to be independent if the probability of getting A after B is equal to the probability of getting A. And likewise, the probability of getting B after A is the probability of B. So exercise 3. A survey of 57 6th graders was done to determine which subject was their favorite. The results are shown in a table below, sorted by gender. Does it appear, based on the data in this table, that the preference for math as a favorite subject has a dependence on a student's gender? Show the analysis. Okay, so we're talking about just the math section, so let's just focus on the math section right here, right? The probability for a male to take math as his favorite subject was 10 over 18. And the probability for a female was 8 over 18. Does it appear, based on the data, that the preference for math as a favorite subject has a depend on the student's gender? Show the analysis and you're finding. Well, actually it does. Because if you look at it, it's for male it says 10 over 18. For female It's 8/18. That's just for math. B says, does it appear based on the data in this table that the preference for social studies as a favorite subject has a dependence on student gender? Well, again, that's for female, it's going to be 10/19. For male, it's going to be 9/19. All right? So you would say slightly more skews toward female. There's a nice test for independence that can be applied easily. It comes from our formula for conditional probability from the last lesson. So it says, given that the probability of A and B, so the probability A and B over the probability B equals, do the following. If A and B are independent, then rewrite this formula to solve for P, A, and B. Obviously, that would just be, right? Let's see this. Remember, the formula looks like this right here: P, A, B, equals P, A, and B over P, B. Right? So obviously, I would just cross multiply. And so P, A, and B times P, B equal P, let's put an and, the sign, right? So then the B says the probability that a person is left-handed is 12%. The probability that a person has, the probability they have brown eyes is 42%. And the probability they have brown eyes and are left-handed is 2%. Is the event of having brown eyes independent of being left-handed? What's your answer? Probably a person, 12% probability. And they're quite independent. Because again, if you're looking at this, right, the probability of one before the other would show that it makes no sense actually for if you have brown eyes, then you're left-handed. Probability. In fact, in the cases that they had, you only had a 2% probability, but one was not dependent on the other. Anybody have any questions on this? Please ask me. There's no more questions on this, guys. Then I will see you guys again on Thursday. I'm going to end the live stream right now. For those of you who look at this after the fact, please leave comments in the comment section, and I'll be sure to look at them and get back to you. All right? So that's all.